All right, so again, the assignment was to give you a quick introduction. There are a number of parts, and this model goes into about 6 or 7 different ways to build these pieces out. So the first one is to just create these items. So right now, this is in the exploded view, and one of the common things that comes up is you do not need a separate part for your exploded view. It exists in the assembly. You can carry it over to the drawing, and if I double click or I right click and say explode collapse, it will explode and collapse as needed as part of our interaction. So the video that is already up that was produced last spring kind of walks through the process. There are some optional items of what to look for in the 3D print. The 3D print has gotten a little bit more functional, I'd say, so I will touch on that briefly. But as you go through building, we're looking for some specifics, at least from a modeling standpoint, and it doesn't matter if it's Fusion, Inventor, SolidWorks, NX. They're all going to have very similar rules in that you need a fully defined sketch. There are no happy accidents. Right? So if I open up, I expand out and I look at a part, and I look at any of these features, if I see minus signs in front of these, that means that part can move in unexpected ways. It can grow, it can shrink, it can have unexpected consequences. So we want to get to fully defined sketches, and that's where the relations, that's where your dimensions, taking that little bit of extra effort and figuring out how do I get this over the top so it is a fully defined sketch. So if I, let's just open up the spacer piece. And one of the things with this spacer, I produced this for the class. So this is a configurable item, and you're not expected to be going into configurations and into that kind of higher level. But that same where I looked at the exploded view, this has all of those pieces that we would need in one part file. So building up and going into it, you may want to take a look at those, how to use the tables, how to expand on it, because we're just drawing whatever 4 pieces, and we're going to utilize those in a bottom-up assembly. Right? As your models become more complex and you want to bring more of this information in, there are some distinct advantages to having patterns, to having this other geometry. So what I was getting at was, if I edit this sketch, mine's going to look a little bit different because it's being driven by the table, but I should not see any blue dots. All right, so if you open up your sketch and there's blue dots, that means it can move. And not always in bad ways, just that it can move. All right, so let's just get out of that. And I'll discard the changes. I'll grab a new one. We'll just start with that. Also, if you're using the novice, these are the default SolidWorks files. There's not a lot of options in there that I believe the video kind of went through just the basics of setting up a template, putting in your preferences, streamlining the process of opening a part or an assembly. So to get to those, you want to be in the advanced, and then this is my accumulation of templates based on what I need or what I want to have the model. So things like the little blue origin showing up when I'm in the screen, it's in isometric. I'm in inch, pounds, and seconds, or millimeters, grams, and seconds. How many decimal places you need. You can build all of those into that template, so it's worthwhile to take just 5 minutes and make these settings, identify them either out of the, let's see, that's going to be the little eyeball, and be careful of the little eyeball because if you click on that, it's going to hide all, and the little down arrow is going to give you access to those selections. So the little green dots that may be taking over your screen as you apply more relations are the add relations. And so if I click on that and then I go into a sketch, I'm going to see for every object its relations. And I want to be in just a regular corner rectangle, and we will sketch. And I say little green dots, and then I remember that I loaded 2019 and they changed little green dots to little gray dots. All right, so you're either going to see little gray or little green dots depending on which one you're using. Main thing is that these verticals, horizontals, I don't have to have those, and as your drawings become more complex, they're going to take over. And so at that point, we would come and hide the sketch relations. All right, so if you are not in the habit of attaching some portion of your sketch to the origin, that would be a very high recommendation that any corner, any point can be attached, and it will jump. You will see that little yellow box. That little yellow box gets you to a coincident relation that now the two lines that are in black are defined. And then what is left is I can rubber band, and that's what I mean by if it can move, it probably will. So at this stage, we can put in dimensions. One of the questions was about tolerancing. You can tolerance at this level, but this is the time to start thinking about it. It's not necessarily the time to delve headlong into it. So let's just go 2 inches by, we're close to 5. All right, so everything in that sketch goes to fully defined. And in the bottom right, if I don't overhang it, on the status bar, it tells me I'm fully defined. So as you go in and you build up and generate more geometry, at each step you're going to want to make sure that you're fully defined. All right, so one of the other questions that I get quite a bit is the patterns. And so if you're doing a whole pattern, the linear sketch pattern requires a seed geometry. So usually that would be a hole. All right, so if I just place a circle, and we'll give it some definition. So we're at the 0.4, and I want to locate it off of one of the edges. Don't know how that's going to work, so we'll just keep putting in numbers. And 0.5. All right, so whether this is a circular pattern or a linear pattern, one of the things with your patterns, especially sketch patterns, is that they do not typically go fully defined on the first go around. You have to do something in addition to make it work. All right, so if I grab the linear sketch pattern and I pick my object, then I'm going to see let's see, we're at 0.4, so let's stay at 0.5. And I want 5 or 6 of those. And if I don't do a dimension X spacing, that one's pretty handy. So if I dimension the X spacing and the fixed X direction, I think previous to 2016 or 2017, those options weren't available, and you had to put those in manually. All right, so yes.
When I do that, I not get the direction arrow.
Okay, so once you hit Tab, and I may have overlooked it, my index finger jumps up there and hits Tab and shows the preview. Once you have the five circles, then it's showing you the direction. Okay, and then for the X spacing, and then the X direction axis, that's going to apply a horizontal. That was not available previous to 2018 that I remember. So to get to a direction 2, if you're doing an array or a square pattern, then you're going to have to activate the direction 2 y-axis by giving it a second row. And then as soon as it has its second instance count, then you can put in values for that row. And as you increase, it's going to pull up. All right, so once I accept that, notice that my X went okay, but my Y still has that issue. I did not check those boxes for the vertical. So in that case, if I were to select, I am missing a dimension, and I also need a relation, and I can tell that by the way that this moves. All right, so if it gets away from me, I can always do the everybody's friend Control Z. And in the little box or over on the property manager, I will tell it that it's vertical, and then it needs a dimension, so between the two, and another 0.6, and then it will go fully defined. Same with the circular sketch pattern, is that it's going to ask for one more piece of information. So I'm just going to try and do that on top. We'll pick one of these out here, and your circular sketch pattern is going to be underneath. Shows you the circle, and then we can either dimension the radius. We have a total of 4. Let's make that 8. And one of the things is it's always going to point to the origin. So if you need something different, then you can offset the X and Y position of the center and get to a new location. So let's go ahead and accept that one for now. It's got a little bit of a shift in it. And then what is not commonly, well, I know it's there, and since I accept it, it's probably going to stay, is usually there is a point right at the middle of that pattern. And that point is what is currently defining our location. So everything will move, maybe. Okay, so when I drag away and it goes fully defined, it won't move now because that point, that phantom point, so to speak, is linked to the origin and all of the other information was tied to it. It's not really a problem, setting up your geometry, setting up that circular pattern until you're in the whole wizard. And the whole wizard takes those points and does an instance count, and you will find that in your drawings you have 8 holes, but it lists 9. And the 9th is that point that it put right at the center. All right, so a lot of times we'll take and see if I can delete that point. Everything goes back to being underdefined. It will stay in the circular pattern, but now it's free to orbit. All right, so we have to either create a base circle, create additional geometry, go through a process. And most of the time I would recommend that you create a base circle anyway, just because it's more visually makes sense. So if I bring my circle out and then I go to another coincident, 3 points will define the pattern. All right, so those go to being defined. And somewhere there is a distance that I'm missing in this. If it keeps coming back to this, well, maybe that one. All right, and then because we don't need a big circle as part of this this geometry, and I don't want to go back through and pick each individual circle so that it becomes a part of a solid body or otherwise. The construction circle is to pick the circle and switch it to construction geometry. So on the pop-up, it's the second on the bottom row, and under the options, it's for construction. All right, so when you're creating, and this is going up into higher complexity than the assignment, but when you're creating this geometry, these are some of the little tricks and traps that you're going to run into in using those patterns. All right, so going back to the spacer plate, I use a pattern. So one path is to take and reuse, repurpose. I draw the 1 by 1, and then I save it, and then I save it as the 2 by 2, and then I save the 2 by 2 as the 3 by 3, and I build up through those patterns. The other option is to use configuration, and each one has its pluses and minuses in the complexity of the geometry. So you're building 3 parts. You have the our little 1 by 4 spacer plate. And no, we shouldn't have to save that, and we can discard. And no, I probably don't need that. And then we have the C, the C bracket, and then the peg. All right. And so as you go through and you go do the assembly process, these parts are just intended to give you an idea of the 6 degrees of freedom, the relative positions of the parts, and thinking through the process of adding. So one of the things, let's go ahead and one of the things that comes up, so I'm going to kick this out so I don't, let's see, we have the other parts. And so instead of a part, I'm going to open up the assembly. And then when I go to insert that part, I can browse. And then I'm going to bring in the spacer plate. Now this spacer plate is based on configuration, so I need to find my spacer single. No, should show me the preview. Well, we'll fix it in a minute if it doesn't. All right, so it comes in. It's not in the orientation that I'm visualizing. All right, so when I say that we design for convenience, if you draw everything in the front plane, when it comes in the assembly, it's going to be in that orientation. It's going to be in the front plane. And that's not always the desirable location. So this rotate context toolbar will allow you to rotate about the axes. And so looking at the reference triad in the lower left, I can see that I'm going to be rotating about the X. And once it's in position, if I just select the checkbox, it's going to put the origin of the part on the origin of the assembly. And then instead of, and yes, it's for education, and then instead of showing me the relations that I need to add, this is going to show the F, that it's fixed. If I want it in any other orientation, maybe I left it in that front plane, that is where you're going to have to right-click and float. So once you float this, then it's going to be free, and you take on the responsibility of setting the mate relations to the front plane, the faces of the part, or to other geometry. So does everybody have a handle on kind of what's going on with the parts and the assemblies? Kind of mostly.
Chance to ask questions.
Take a few before we keep running through it. Okay. So as you build these parts out, and then it comes into the assembly, there are a couple of tricks that I throw in there that if you want to utilize the mate references, that if you are going to be inserting a lot of pegs, pins, or geometry, you probably won't want to go through one by one and say this is coincident, this is concentric, this is whatever. And that's where you would go into the part. And we saw, I think it was on the peg. Is on the peg, you will be able to set a mate reference that has a default setting. So when I drag this in or I move it around, it will automatically snap. And as long as I keep holding down the left mouse button, I can hit tab to reverse it. And so those mate references are under the reference geometry, mate reference, and when we pick just a face, then it's going to default to that face. If we pick just the cylinder, it defaults to the cylinder. But if I pick the edge, this is the one place where it will give me both a concentric mate for the cylinder and a coincident mate for the face. And then when I drag it in, it orients the part to where it can find that geometry. All right, so I think those are all in the video. So what do we want to do for the drawing? And find that guy again. All right, so once you have the parts, you've created the exploded view, and we already mentioned that I can expand and collapse. So once you have your part generated, then going into the drawing, we tried to keep it on the simple side without getting into the drawing templates or into the other geometry. Also, 2017, 2018, Solidworks had an issue with the drawing sheets to where it referred back to the first document and wouldn't let it update. That has since been corrected. So what I was shooting for was there is a whole nother level of going into drawing templates and creating these drawing sheets. So if I grab, well, I'll look at the sidebar one. So this is something to go through, and it has those relations. Each of the parts travels with its metadata, and then when it makes it into the assembly, it automatically populates my drawing template. All right, we didn't want to go to that next level of complexity, so when you're bringing in the part, you have the choice of making a multi-sheet drawing, in which case you'll see sheets populate across the bottom, or a lot of companies will say we want one part per sheet, and you name per this convention, and you follow their instructions to create your parts. I like the multi-sheet mainly because if I need to print, if I need to grab everything related to that document, I don't have to open up multiple documents. I can find it in the one sheet. So bringing in a part, since this opened, we have a couple of options. You can do the model view, which if it's set to start the command, by default you will probably see that every time. And then the other option is to go to the view palette, and it will find the items that are open. The nice thing about the view palette is once it grabs the part, it will give you access to the isometric exploded, the front views, and once you start to drag those in, then you can populate the views. And so if I just grab that and bring it in, then I get it in as its last configuration. If I don't like that one, I think I like the exploded view 2 I did, I would just change it, and that looks a little bit better. All right. So you've gone through, you followed the video, you get to a point where you have the dimension drawings. We won't go through all those. I mentioned the tolerances, so I do want to kind of start with those. So let's bring in a spacer, and my sheet format could not be located. That's interesting. Cool. All right, so maybe we'll do it on this one. It'll default to the A size. All right. So one of my issues with the default A size is this takes up a good third of the sheet, and so I would rather see you, if we edit the sheet format, I'd pretty much rather see all of this go away. And if I go left to right on my pick, it will find everything in the window, whereas if I go right to left, it will find everything crossing the window, except for one or two things in the bottom. All right, so if I were to do something like that, I have just a really basic sheet format, and I'm going to have to build my title block. Well, we're only tracking two things, your name, a date, and the part name. So you should be able to put those in as annotations. And I will bring in from the view palette, I want to search, and let's go ahead and bring in the spacer. And it was not a triple. All right, so once I bring in the front view, I really don't need a top view per se, since the side view will take care of, but I would like to have an isometric view. All right, and then I'm not real happy with the size, so the 1 to 2. And the bottom right, the quick way is to pick and go to the 1 to 1. We can also go to the sheet properties, a right click, and I'm not sure if that one stays. So properties sometimes gets kicked off, and I end up removing the delete. But this is where you're going to find the scale, and also if it happens to default to first angle projection versus third angle projection. Third angle used predominantly in the United States is that the direction that you're looking at these views. If the isometric kind of comes off this way and everything looks kind of backwards, then I would check for first angle. All right, backwards to what we're used to seeing. All right, so once we get into position, if you need to take it to the level of the GD&T, my new favorite obsession with tolerancing, we'll go back over into the annotations, pick a smart dimension, and once I place a dimension, the parts were generated in metric. So going to an inch drawing, I'm going to see those same numbers just carried over. All right, so if I want this drawing to be in metric, then I'm going to have to come back over to its units. And if I just pick millimeters, grams, and seconds, it's going to update, and then it's going to follow the metric standard. We don't need decimal places. We don't need that additional information. Okay, one more. And except for the whole locations, this will take care of the outside dimensions. All right, so one of the reasons I didn't need the top view is that it doesn't add value or doesn't tell me anything that I can't already see. All right, so I'm a little more familiar with the inch dimensions, so I think I'm going to jump back on you guys and set it to numbers that I'm a little more familiar with. And so when you pick on a dimension, in the dimension side on the property manager, you're going to be able to pick, is this a basic dimension, a bilateral, a limit dimension, a symmetric. So bilateral would be a +5 minus nothing. A limit dimension would show you the numbers, the upper and lower limits of the numbers. The symmetric is just the standard ±2, ±5 thousandths, ±10 thousandths, whatever you want to give it. Then it goes into the min and max notations of conditions of typically holes or internal geometry. And once you get over into the fits with tolerances, then we start looking at FN numbers or P numbers, and you go to the tables and you figure out, wow, does this need a hole that is 1,000th smaller, 2,000th smaller to fit the requirements of the fit? If it's a running fit, how much clearance does it need to have that running fit? All right, so once we picked, we've chosen a dimension. then we're going to give it its value, so it can be a plus 5 thousandths, and it will add it to the mix. And the only real recommendation is that you don't mix it. Once you've kind of picked a dimensioning strategy, is stay with it. The numbers need to be kind of consistent. So if I was to go to a symmetric or a limit dimension and do the same thing, I can put the number in for contrast, but unless it adds value or is calling out something specific, it's not going to help you. All right, so as you go through and get to these higher levels, you start thinking about your tolerances. Pretty much there's the 3 levels. As you're going through the part, you start, and then as you're building in and going into the assembly and you see how these pieces fit together, then you can think through the terms of, oh, this part can't get any bigger, this can't get any smaller, this has to be in these size ranges to ensure that your parts are going to work. All right, and then if you want to carry it over to the geometric tolerance, we need a symbol, and we'll go into the form tolerances first. So I will pick a flatness. Usually the flatness will be the, let's go with 5 thousandths. And I can place it, and apparently my layers didn't come up. And then if we want to kind of drag that away, it'll pick up the extension line and give it more of a flag look. So depending on where you place your dimensions, start to apply the GD&T. That also becomes then my datum feature. So once I have a flatness, that can be the datum to refer. And then carrying it a little further, we'll go into parallelism. And if we go parallelism of 5 thousandths, and its primary datum needs to be A, then we can apply it to the other side. All right, so the GD&T takes it up another level, but it ensures that you're going to have the fit as you send these out to the machine shops. These are critical. So one of the things that I like to kind of reinforce is that as you're going through the assembly and you think you need something this is very important, this is critical, then you will want to start thinking about flatness, parallelism, positional tolerances, and going up through those next levels. So the pegs at this point are line-to-line fits. There's no additional geometry, so at a 10 millimeter 394 fit, the parts, the pegs can slide in, they can rotate, there's no real press. We haven't taken that into consideration yet. So what is it that we're doing with this fastener or this piece of hardware? So each of those questions has an associated tolerance to it, takes you to that next level in your design. You do not have to go to this level in your assignment. I want to put it out there so if you're thinking in those terms or you want to utilize that, you have a little bit of direction on how to apply these to get these annotations, to get these dimensions onto your model. All right, so questions? That help with the assignment, or did I cover enough of it to get you going? All right. So the thing is that there are, that was the surface finish. Surface finish is another whole conversation. There are other items in that group that if you are interested in building it up or building it out, then the assignment goes through a total of 7 different models. All right, so it's actually kind of a neat process and a great introduction to assemblies to go through each of the items and see the types of things that orientations, the things that are going to arise as you go through the assemblies. All right. So might as well save all, since this is my 2019 version. When I hit save, all of the parts that are associated are now 2019 files. They will show up, they will be labeled as future version in 2018, but I cannot open them and I cannot edit them. So be aware that most all of the modelers are forward compatible. I can open this 2018 file, save it, and it becomes a 2019 file, and then when I try to open it in my 2018, then it barks at me. Then it tells me, I'm not so happy with you doing that. And 40 seconds on the drawing. Okay. Well, we'll let it catch up there. All right. So outputting these. Oh, we had the. I didn't need to close that quick. All right. So you get to the. Oh, now it's going to take 40 seconds to load. Nice. Not too bad. All right, so you get to the point where you want to output this to the PDF. You want to output it to some other file extension. This is going to be your file save as. All right, and if you have the Adobe Acrobat installed, it will act as a printer, so you can just hit print and send it to the Acrobat as a standard. Or if you do the save as, then under the save as type, we're going to look down through until we find the PDF files. And then as far as the options, you'll want to tell it that we're outputting. We're going to go ahead and let it do the colors, the standard fonts. And I think it asks, okay, it asks a little later that if we want to put out one or all of the files, or all of the sheets. So when I hit save, it comes up with a PDF export and sheet 1, sheet 2. If you have 20 sheets, it's going to say, do you want all 20 sheets? And then by default, they're selected. So once you hit OK, that's going to output it and generate your PDF file. So that kind of is the easy way to see the model, to be able to interact with the drawing, but that doesn't give you access to the parts. So as a customer or as somebody that needs your files, one of the things with the drawing and the assembly is they do not consume the part. The drawing does not consume the assembly. They are still individual items, and you have these references to them. And so if you only send the drawing file, well, we'll let that catch up. If we only send the drawing file, then chances are I'm going to see a nice yellow box with nothing in it, because I don't have your assembly, I don't have your parts. All right, so that's where the pack and go comes in. If you're going to send a model, pack and go is a utility that we can, under the file, come down to. And then this is everything that's in the list. You want to include drawings, then we need to click on the drawings. If you had simulation results, the toolbox components. If you know that you're sending to somebody that has a basic level license, they may not have the toolbox installed, so they won't get the fasteners, they won't get the pins, the retaining rings, the washers, the nuts, the bolts, the whatever. All right, so in that case, you'd want to include the toolbox components. Decals, appearances, let's see what else. Suppressed components automatically, and then nested view and flat view. So under the save to zip file, it's going to take on the drawing name or the file name that we last were working with. If you want to flatten to a single folder, this is one that you're going to have to experiment with. I've taken several hundred piece assemblies and gone to do pack and go, and when it says it's going to flatten the view to a single folder, that means every subfolder, every subassembly, everything gets dumped into one folder. And now instead of having everything neatly organized and the way that I should recognize it, everything's in one folder, period. All right, so you'll want to experiment with that and check flatten to minimum folders or keep the full folder structure. So as you get more complicated, you'll have to get more complexity in your models. You'll have to experiment with that one. And also, this is a great way to back up. If you're doing revisions, you're about to take a what-if scenario and really, take a hard right turn and, wow, I'm not sure what this is going to do. This would be a great way to take a timestamp of your model and secure it so that if the right turn doesn't play out, you can come back to it. You can get back to your starting point. So that file will be under our model, and actually I should have seen where that was at. And so if I need to find out where the model is at and I open recent, I should be able to hover over any of these, and that was the Chapter 5 assembly. And come back. All right, so there's the zip file, there's the PDF, and we can preview those and go through the process. So as you go to upload or to email those, then you can grab those files just as attachments. All right. So we'll close those out, see how long it takes to save this time. All right. All right, so the other question that I got was planes. And planes are one of those that you shouldn't need a whole lot of them. That if you create the geometry, if you're dealing with mostly prismatic shapes or cylindrical shapes, they're not going to be that useful, because you're going to be able to pick your geometry on those faces, on those planar surfaces to create your geometry. There are some instances, though, where it will come in handy. So I'm just going to start with a cube. And so about that size and about that big. And since we're 2 by 2, we'll go with another 2. Okay. So one of the things to watch out for, on the rare occasion that you happen to select and have selected a line and it's in point, and you tell it to go into a sketch, you're going to get a plane. At least you used to get a plane. Let's go ahead and draw something and see where it goes. All right, and when I accept, I get plane 1. That plane was created because that is the logic of a plane at an endpoint. Let's see, would that be tangent? Well, it's straight line, so it doesn't qualify as tangent, but if it was curved, it would be tangent at a point. All right, so that comes up automatically, and so you may see these planes popping up, and, well, I didn't tell it to do that. That wasn't what I wanted. And so like I was saying is, if I really wanted a circle on this face, all I really have to do is pick the face and then go in and sketch the circle, and I really didn't need a plane to do any of that geometry. Where planes come in handy then is, again, as the geometry becomes more complex, as you're building in more shapes, then we'll want to do some more of those fun things. So front plane, if I hold down the control button while it's highlighted and drag, then that is the easiest way to get a parallel plane. So I can offset it, I can bring it out some distance, and so a parallel plane with a distance of 2 inches. And then when I accept it, now I can start a sketch on that face. One of the comments one of my students made was, I really don't do that because inside of the extrude, if I needed something to start over here and go that way, I can offset the sketch. So that kind of negates even more planes that I might need. So keep in mind, there are all kinds of strategies. There's no rule that says you have to do it this way or that way. It's the way you see it. I always say there's no right and wrong so much as the validity of the part. At the end of the process, if we both drew the same part and my geometry matches your geometry, I don't care how you got there. If I did it in one sketch, but that sketch is so complicated that nobody can decipher it, including me, it's not very useful. If I did it in 3 or 4 sketches and 3 or 4 features, and it's much more approachable, you are better off in the long run. So, keep the geometry manageable, and where you what you see the first time around, trust your gut instinct. All right. So if I go back into my features and reference geometry and just go to plane, then that plane was selected, so it's automatically going into another distance. Well, if I wanted it parallel and then pick a second reference, then I could pick any existing vertex, face, any geometry that is accessible is available. Okay. Where this gets a little more interesting is under the plane. When I go into compound planes, well, that was still selected, so I need to get that out of there. If we pick 3 points, and the cube will set that up for me. All right, so a line and a point, and I got one too many there. All right, so let's take that point out, and we'll go to the opposite corner so that we get an angle. then that plane actually can be used as a cutting surface. So under the tools, under the insert, cut with surface, that plane is a valid piece of geometry to say, I have a cutting tool. All right, don't really want to cut my cube, so we'll call that good. If I pre-select the 3 points this time, and go into the plane, they should show up as the first, second, and third references, and then I have a compound plane going through each of the corners. All right, so when setting up those geometries, you're kind of relying on the software to minimize, to make selections based on your picks, and go from more complicated to less complicated in your choices. So coincident, 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 and then we're not really projecting anything to that geometry. Once I have the plane, now it's valid to sketch, to create our geometry, to build out our next shapes. All right. So let's hide the body. So solid bodies are one that comes into our strategies, our 3 main strategies. So at this stage, you're probably doing bottom-up assemblies. You create the parts, you bring them in the assembly, you see how they fit together, you make changes, adjustments, and go through the process. Top-down, and hopefully I have my top-down example, is what I did with the pulley that I'm working on for the lander drop. And it was a quick way of making the geometry, but it comes with a lot of external references that I have to manage. And then multi-body or master model, as terminology says, that I can build multiple solid bodies and relate them together in this sketch, and then output them as an assembly or as separate pieces of geometry. So once we go through that process, then we're going to have these multiple shapes, these multiple references. Oh, the plane, I forgot one. I jumped through it on the solid body. So let's go ahead and hide the solid body. Have all of the planes. If I bring out the display state, I can go through and hide each of the planes, and then hide the remaining 2 sketches. So one of the things that comes up is, well, let's do it as a revolve. So on a in a sketch, don't see my plane, so front plane, we'll open up the sketch. Anytime you have a revolve, the prismatic shapes are pretty straightforward. The revolve pieces will do a infinite length and 4 construction, and then I just need to find my origin so that I can place it coincident. And then, well, let's go with a kind of a tapered cone. Make it a little more interesting. All right, and then like we said with the sketches, if I can move the geometry, then I either need a relation or I need a dimension. So we'll go 1 inch, and because I selected the center line, well, first you have to have a center line, but because I selected the center line, I get a diametral dimension. And it will stay in diametral until I tell it that I don't want to do diametral by hitting escape. So we'll go to 0.5, and then if I come back to the line, it should kick out because it sees a linear dimension now and move away from the diametral. All right, so features, we'll do a revolve. And if I wanted to put a whole wizard item, since I brought that one up, we kind of need a location, and I would like to be tangent to this surface. All right, so to be able to clock, just saying that I'm tangent to the surface doesn't really help me. But if I draw some construction geometry, and I think I missed one of those, and then any 2 non-parallel lines are going to give me an angular dimension. So 50 degrees is fine. All right, so that sketch at a point and control selecting the surface will take me into the plane. And now I can control the location of that plane on that surface. All right, just placing it doesn't give me the same level of control as producing that construction sketch, because now I can go in and say, no, I really needed that at 120. Okay, maybe not 1200. There we go. And then Because the sketch does not automatically rebuild because I'm not currently in the sketch, I have to manually rebuild it. That will bring the plane around to the other side. So when I go in to do a hole wizard, as long as that's selected, S key will take me quickly to the hole wizard. Now I have something that I can put geometry, a counterbore, a countersink. Now let's just see what that looks like. We'll put the position. That rotated a little bit on me. That's interesting. And that is way too big. So we'll go back and make that just a little bit smaller. All right. So I can see the default geometry, and that will put me with that geometry in the on the surface. Interesting. All right, so a quick comment about the top down. Any questions before I jump out of the planes? All right, we'll see if this comes up, and then we're probably getting close to time. So don't get me started talking about Solidworks because we'll be here all night. Now I got to find it. And I know I copied it. Well, maybe we won't go into that one. Okay, I should have identified that one first. Okay, we'll do this the quick way. If you decide that you want to do top-down in any of the assemblies, in any of the programs, be aware that one of the first things that you're going to want to do is save your part. All right? So before I even bring a part in, before I even do the assembly, I can come back and save. And we'll leave it example. All right, once I have that assembly in place, then being able to tie the geometries together. So a lot of the kind of by way of explanation, a lot of the videos will encourage you to do top-down assemblies, and they will tie part to part to part to part, and any one of those parts becomes a domino. You pull one part out, then it's going to have a domino effect of issues as you go through. So my recommendation is that if you want geometry that is going to be common to all of the parts, that we create a sketch, and it's going to be, and I'm not sure why I'm not getting my planes. Okay, that's still interesting. Is that we create our geometry, and this sketch only serves the purpose of being a single point of failure for as much geometry as we want to place in it. If we tie everything to everything else, then those external references become a spider web that as you pull on one string and it starts to unravel, it gets a whole lot of red and yellow on your screen. So let's just bring up the whole location and go ahead and accept. And so for the top-down assembly, we go into the assembly tab. Instead of inserting a component, I'm going to do a new part. By default, I have told it that it can come in as a virtual component. It will not exist outside of this assembly. So I'm just going to click so that I have a new part 3 at example. And when I edit that part, now I can pick all of this geometry. I want the front plane of the sketch. And I can pick any of the geometry that is useful. So if I grab the chain and convert entities, or I trace over top of it, the resulting new part is going to have very few or no dimensions in it. Everything is going to be driven by this top level layout sketch. All right, so keeping it in mind, this is an advanced, and I got one question on this, so this is more to kind of take care of that than it is to say you need to do it this way. All right, so this part becomes, and then we go into the face, and let's just say that is a location. So one of these can be a, now let's just go ahead and convert it again. And then we'll extrude cut the assembly, or extrude cut the part through all. And then that becomes my part 3 at the assembly. And then going in and making the next one is a new part. I really want to hide that, so yeah, can't do that just yet. So if I hit tab, that will hide the values, and then shift tab will bring back the part that I just hid. And then same thing, I need to edit the part in the context. And we open up the sketch on the front plane. And same thing, I can select the chain and convert the entities, and then this will extrude the boss base. And 1 inch is fine, but I want it to go the opposite way. All right, so now when I go into the hole wizard and we pick a size, let's make that a tapped hole, and 1/4-20 will be okay. I'll set the position, then I'm just setting the position to that one item, and even that hole is a little bit big, and we'll go into the position and we accept. And then notice that these are coming up with the little arrows. All right, so the dash greater than symbol is telling you that there's an external reference. This is where you can get into trouble, because as we name these, it's going to continue to look for the reference. It's going to look for this file name. We tie everything back to this one file name. Going into Windows Explorer and changing names is not a good idea. It will lose its mind, or you'll lose its mind trying to figure out what it did. All right, so when I show this component, those 2 items are tied to the sketch. When I want to make a change, well, I didn't put a dimension on it, so I'm actually going to have to drag it. I want this over here, and then we rebuild. My geometry follows it, and not just one, but both. So the advantage is I'm less likely to have mismatched holes. I'm less likely to have things not line up in assemblies, but I take responsibility for my model. Right? And all of those external references and everything that's being tied together, you're going up a level in complexity. You have higher expectations for the results of the model. Are we good? All right.
Good. And I want to make sure, did you cover, because I said about a minute,
Yep.
did you cover what they need to hand in terms of that assignment?
Yeah, we did the PDF and the pack and go, so I'll let you kind of, which?
Yeah, just send me those.
Okay.
Or if you have it on paper, so you can hand it.
Yeah.
Does anybody
Paper's
have
always
any
good.
questions about what to hand in? Is it clear? Because we were getting some questions earlier downstairs. Russ?
How does pack and go work?
That was, all right, so let me pause. We're going to put this video up.